Test, test, test. 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 Uh-oh, I think I broke it. Test. Okay, not broken. All right, I'm just gonna wait probably like 3 minutes and then we'll begin. And if you have any questions during this, the slide thing link is up there and you'll be able to ask them there. As well, if you ask in the Twitch chat, I can pin the comments like this and then we can pull them up and I'll just answer them. You can ask throughout it or you can wait until the end and then I'll just go through them. So, but anyways, it's Friday, start of the weekend. Yay. So I appreciate those who did come. You know, it is Friday. It is going on to the weekend. You could be, out at the bar or something. I don't know what people do these days, but you could not be here. You could be playing Rocket League, I guess. But instead, you decide to learn about the wonderful land of infrastructure for developer, which is what I originally called this. But I think the better talk for this would be Kubernetes for developers, or what I wish I knew, or what I wish developers knew before deploying to Kubernetes. So with that said, kind of the way I envisioned doing this is essentially walk you through a bunch of different stories that over the last, I'd say, 2 years, either I've stumbled into or people I've worked with have stumbled into, or other people in the industry have let me know, and just common things that I kind of see that even myself as a developer, not realizing that the infrastructure is doing behind the scenes and just being oblivious to this. So, one of the things I think is latency spikes. So, for context, let's say that this is your application. So you have green could be some sort of web server like Node.js, and Redis will say something like Redis. And you have these bunch of different nodes in Kubernetes. And you have your containers, which are running in pods, and those are deployed onto nodes. Now, it's very easy as a developer in your dev environment or your staging to think like, look, how could this ever be like faulty? It scales up, it scales down. And then I ask you, well, what does it look like in prod when you scale up the application, but you didn't scale up Redis as well? Because they're not coupled to each other. You don't necessarily scale in your pods in Kubernetes as like a group. Like you say you scale like, oh, I want to scale Redis and X thing together, like Node.js. So when something like this happens and we end up with a diagram, as you see, you can be adding on more, let's just say Node.js. You could be adding more Node.js, but those Node.js services now have to try like go through the network to another node versus what you saw before, which is they're on the same node. So they just do local loop back, and they don't actually have to go out on the network at all. So you could be scaling up your web nodes with a autoscaler in Kubernetes, or just manually scaling up and not even realize. And all of a sudden you're looking at your graphs and you're like, why is the latency spike going up so much? Why are things taking so much longer? And the worst thing is in Kubernetes, if you have this on what's known as the HPA or horizontal pod autoscaler, this might happen. And then you come in the next day and see a graph with a giant latency spike and be like, oh, I don't understand. Why was everything taking so much longer at that time? And you think you've introduced a bug, or maybe there was a lot of traffic and you're trying to correlate this, and you're just really trying to have like a concept of what was the state of the cluster at that time and how did everything look in terms of pods on nodes. So this is really something common for developers who are deploying for like the first time and having a latency spike and not realize like, oh, if I have dependency on other things, I need to be aware of this, right? I need to either write it a part of what I'm deploying, or I need to let the infrastructure team know, or we need tooling so that when the web application scales up, also Redis scales up on an equal kind of number. A common other thing that I see, which is similar to this, is unpredictable performance. And you know, throughout the day, you're all of a sudden like, why was Redis so slow? Why was the web server so slow? Is the underlying infrastructure could be changing, and you might have no idea. It depends on how you've set up your spec. Have you set things like node affinity, talking about, hey, this pod should go onto these sorts of nodes. Like I want my Redis pods to go on high memory nodes, or I want my web servers to go on more CPU kind of style nodes to get higher throughput. So the developer checklist, right? What can we take away from this? Well, you definitely want tooling and work with either your SRE or your DevOps or build it yourself. But you need a way to essentially take snapshots or have the logging to look at exactly what the Kubernetes cluster looked like at any point in time. Because the worst thing as a dev is you have a giant latency spike graph and you're sitting there going, why did that happen? What was the context? What was the state of everything during that spike? And if you don't know that it was because you had disproportional amount of like, the web server pods on 20 nodes and only 3 Redis pods running on 3 other nodes, and that was causing everything to go back to these 3 nodes. Well, it's going to be very hard to investigate, right? So we want to identify, as I was mentioning, the cross-pod dependencies. We need to know when we have close coupling, like we depend on something else. In this case, for example, it's Node.js and Redis. It could be Java framework like Micronaut and Redis. It could be your database, like a Postgres database. Anytime you're doing these close coupled service calls, microservice between microservice, right? So we want to apply pod affinity, which is just a fancy way of saying like, I want to deploy these pods in the same together, essentially is what you're saying. I want Redis and the web server to be deployed together at the same spot. And then you have node constraints, which are node affinity, which is I want these pods to go onto a particular type of node. I want these to go on the more high CPU kind of instance types that we have. Now, what I will say about pod affinity and node affinity is we have the option of setting it preferred or mandatory. So maybe for the most, and it's on the preferred, you can set a weight. So you could say like, my preference is like 90% of like 90% of the time I want to be coupled. 10% of the time on the weight, I'm willing to go elsewhere if I can't go anywhere else. Because you would rather scale and have the latency bump than to not scale at all and have requests dropped. So this is the developer checklist for the first kind of thing that I see, which is just fundamentally understanding what you're deploying and either building it within your YAML specs yourself if you're responsible for the charts as a dev, or making sure that your DevOps and SRE teams are aware of, hey, I really depend on that other thing. And if I have, if that's in another region or if that's not on the same node, like it's gonna be very slow. So another gotcha was struggling to scale by mistake. Now, we're going to talk about a Node.js application in this case, because that's mostly where you're going to see it. You could also see it in some Java applications if you, I guess, aren't fully handling like multi-thread and things like that. But so in Kubernetes, we write this thing called HPA, horizontal pod autoscaler. We define the resource that we're monitoring. In this case, it's CPU. And then we set a threshold. In this case, the average utilization across all pods, when it exceeds 60%, it will start scaling. And then there's a bunch of configuration like how many pods up do we want to scale at a time and what threshold for how long do we want to stay at least that, a stabilization window. But in this case, we don't really care about that. So let's say we have 1,000 millicore, so like 1 vCore as our CPU resource request. And someone has scaled out a bunch. We have a lot of these pods running. Let's say we have 10 pods of these running, and that was the max of pods were allowed for whatever reason. And someone's like, oh, we need more resources, right? The issue is more resources. Like maybe you have bad written code and you're just trying to patch it to get through an issue. So you decide, okay, just increase it 4x, right? This will help us. So in this case, because of like the life cycle of Node.js and how most of it's like this single thread life cycle management, for the most part, you're only going to be able to really use 1 vCore, at least on like the web stuff when you're doing throughput. Just a lot of requests that you want to get through as quickly as possible. So if I can only use essentially 1 vCore, and hello, I see you in Twitch chat. If you're using only 1 vCore and then you bump it to say, no, it's fine. The pod can take 4 vCores, allocate 4 vCores for it. And then you look at our HPA and our HPA says only scale up if you're using 60%. But what I just told you was for the most part in Node, if we're doing like a web application, we're stuck in a spot. It's only going to use 25%. So we'll actually never scale. we'll have the minimum amount of pods we have. We'll never beat that threshold, even though all of our pods are from a Node.js perspective at 100%. They're utilizing as much as they can within that single threaded architecture. But you've given the pod more resources. So from Kubernetes standpoint, it goes, yo, I'm not scaling this up. You got 75% to go, like across all the pods. I'm just leaving it as it is. So the question was, is HPA only limited by CPU, or I wonder if I click the present button, what it does. Oh, wow. I've never used the Google Slides stuff. Or can you define it based on memory? So you can do memory. You can also do custom resources if you would like to. It's a different spec to do the custom metrics, but you could tie this into Prometheus. You could tie it into whatever your favorite tool is. And then you can push these custom metrics into Kubernetes and like cube metrics, or that's just a fancy way of saying like push it into Kubernetes, and then you can serve this up. So you could scale on network packets in, network packets out, open connections. If you have something internal to the application itself, like active users logged in, maybe you want to scale up on that. Typically, honestly, for 99% of the time, CPU and memory are all you're going to need. The few other times I've seen it is like on network. But when you think about it, almost all other resources are constrained by CPU and memory. You are going to hit your limit on the CPU on some level of your network throughput. So unless you have like very high packet amounts on very low CPU cycle where you could saturate the network card, but not saturate out memory or CPU, that would be the only time we would look at something else. Every other time, we're basically always going to be looking at CPU or memory for whether we should be adding more or not. But very good question. So our developer checklist in this scenario is, so we just have to explain what the impact of our changes should be prior to the change so that everyone's aware. Like when we increased from 1 vCore to 4 vCore, our assumption was that we would not downscale. The auto scaling would still continue, and all we would see is each pod be able to handle more requests. Now, if this was in a real environment, what you would actually see instantly is your HPA would start downscaling, because when it calculates out the average utilization, it would say there's no reason to be scaling at all. It would go down to whatever your min pods is. So if you have this on a graph, right away, it would be very, 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 very clear that your HPA just got turned off, and it would just flatline. It would never increase either. So examine the auto scaling. That's obviously working after the fact. We just made a change related to resources. We should check that everything that interacts with it is still working as expected. You have to, as a dev, unless on the infrastructure side, you need a really good comprehensive understanding of the language that you're working in. Like in this case, this scenario was just known because like I knew the spec and someone had mentioned just like, hey, I have this Node application, and the way that the Node lifecycle basically is handled is it's single threaded. And I'm like, whoa, wait, what? I'm like, so the most you're going to basically be using for throughput is 1 vCore. And they're like, yeah. I'm like, oh, like if you're giving it 4 vCores and it can only use 1, you're only ever going to be using 25%. So you'll never actually trigger the auto scale. So you just have to have an understanding of what you're working with. The same thing if it was like a Java application where you're single threaded and you weren't fully handling like multi-threading, then you could probably pigeonhole yourself in a spot that you might never utilize more than 50% of the resources you're using being given. So you just have to know that. Now, if you have full multi-threading, you can use all the cores, then no problem, right? Like as you increase and use more of the resources, then obviously the autoscaler would kick in and say, hey, I need to add more pods. So the other thing I say is basically the rule of thumb is always expand horizontally instead of vertically. The asterisk is, except when you have very precise tools that tell you otherwise, like Trino is a distributed SQL engine, and they tell you we do a bunch of optimization, and please get larger boxes instead of many boxes, because of the application code is very parallelized, and it's very costly to move a lot of data between nodes, so you want as few nodes as possible. But for most things going into Kubernetes, you're looking for as small as possible, but as many as possible. So small and as many. And then obviously there's the other asterisk is there is overhead on how many pods are being managed by the node, how many pods are in the cluster. Don't go to the extreme. Like, don't just be like, I watched this Corey guy's presentation, so we're going to decrease everything down to one gig and one vCore, but we're going to have 50,000 pods, because you're going to hit other limitations like spamming core DNS, the API gateway in Kubernetes is going to fall over. Most cloud providers only allow a maximum of like 100 and something pods per node for managing, like within reason. So the next one that I think a lot of times this really gets devs coming over to deploying on Kubernetes, their application code, is handling graceful shutdown. I didn't really have a good diagram for this, so we'll just go through it. It's like, okay, for graceful shutdown, in Kubernetes, you have something called termination grace. What is it? Termination grace period seconds. Okay. And this needs to be greater than the total time in your worst case. And what do I mean by worst case? Well, in your code, you need to be listening for sigterm. And the reason why we need to be listening for sigterm is because we need to, just because a pod gets marked as going like sigterm, so you should be shutting down, does not mean that pod instantly is not serving traffic. It does not mean the connections that it has right now are just done, right? It could still be getting incoming traffic. So we need to ideally begin failing what's called the readiness probe in Kubernetes. So this is basically, you have 3 probes. One is a startup probe, which is just the time it should wait before checking if the pod is up or running. And then we have something called the liveness probe, is the pod successfully up? Or yeah, is the pod successfully up? And then we have the readiness probe, which is, okay, should you be receiving traffic or should you not be receiving traffic? Because think about it, you could have an application from like, it started up, but it hasn't loaded all its configuration yet. So the process is running, but it isn't ready to accept actual traffic. So we listen for sigterm in our application. We have the signal. Great. So whatever endpoint I'm using for the readiness probe check, I should start failing to tell Kubernetes, like, you should stop sending traffic to me. It's fine that I have traffic. I can still handle that, but preferably you stop sending me anymore. And then obviously before denying any requests for handling, we probably want to wait something like 15 seconds. Now, there's an asterisk because it gets a little bit more complicated. Each cloud provider has an API interval check where different controllers within Kubernetes will go out and check, has events happened? And this is 10 to 15 seconds, is pretty much every cloud provider. So you want to have enough time that the other controller in Kubernetes that handles what's called endpoints, which is basically a fancy way of saying like, hey, these are all the things that are accessible when you call X. And one of them would be your pod, like it'd be end pods. And, so that could take up to 10 to 15 seconds to actually realize the event that like, oh, that pod should not be in this list anymore. So you have to just be aware of the fact that you could get sigterm in your pod and you're thinking, oh, I should be shutting down. And things inside the Kubernetes cluster haven't even known that they should be revoking you from getting traffic yet. So what we want to do is obviously fail the probe. So if we have a low enough readiness probe, that will notice and then immediately stop it then. But if you have a high readiness probe, then the next spot that would notice it is the endpoint controller would notice this event saying, hey, pod Corey is getting terminated. And it would go in and remove that from the list of available pods to get traffic for whatever thing we're talking about. If it's Node.js, that's a web application, like whatever that service is. And obviously the thing that we obviously need to do is, like any dev knows, is you need to actually allow the connections to finish that you've received. So if we're talking about the HP server and you have a max request timeout of 60 seconds, that means in the example I gave you, you were waiting 15 seconds for everything in Kubernetes land to be notified, and then you're waiting at most 60 seconds. So you're waiting 75 seconds. So your graceful period shutdown should be at minimum 75, probably 80, right? And then that is the time that that pod has to actually successfully consider being done. Now, side note, if you're using something that you don't control, let's say it's an existing application that is in a container, there's a pre-stop hook. Because if it's an existing application where you can't change the code, you might not be able to actually have it listen for a sig term, like a NOAA signal. So we have pre-stop, which is just basically you can define a hook to say like, hey, when sig term happens, this pre-stop hook gets triggered, and I now know to do like the application CLI shutdown or whatever way to do the normal shutdown of that third-party external thing. Maybe it's a Postgres database. Maybe they're supposed to handle sig term, but you get my gist. An application which we don't actually handle the sig term and we can't change the code. Actually, I mean, I could leave that. If you have more questions, feel free to ask. I should have brought more water. This is actually like old cold coffee, but you get like, it's the things I do for you guys, you know. So infrastructure information into your application. This is just a fancy way to say that a lot of devs take the approach of like, I write my code, I don't care about the infrastructure, I shouldn't care about it, I should know about it, like that's not my problem. But I think there are a lot of times we want to be aware of the infrastructure, because you have to realize if you don't care about that at all you are is a container. You have no idea how many resources you were given, how much memory, how much CPU, or anything around that. If you come from the Java world, those are kind of important things to know, because you're probably doing your garbage collection tuning and like your max heap size based off of the memory allocation that you're given. And if you have zero idea, you have zero idea. You just launched a container. So how would we get kind of that stuff? So we have two options. We can have it injected into our container via environment variables or by files. And the nice thing, and what most people aren't familiar with, is the file way, because you have to call something called the downward API in Kubernetes, which is basically you tell Kubernetes, I want you to run an API, and you're going to get these values, and then you're going to provide it in these settings. I actually like the file way. I think it's the more preferred way for this kind of data. And the reason why I like it that way is, so we can expose all this information via downward. I said that, and applications can be aware of it. Great. I like the file way because in the application side, I can actually watch the file, and if the file's been changed, I know that I should reload the configuration or whatever that file has. And you might think like, okay, well, I'm in Java world, so I can't change the GC arguments or the Java arguments after runtime. Like it's already running, so why do I care? Well, what we care is you can do some really fancy things like quick and dirty. So think about it. If I can pass labels, the Kubernetes labels, as into the file or via environment variables, I essentially have basic feature flag system with no code. Like I don't have to write a system to handle the flags. It's all on GitOps. I committed to Git. It's there. The labels in my chart or my YAML definition, and now I can toggle things on or off. And the application would just check. So, and the nice thing is, if you're doing it the file way and you're watching for file modification and you do a live reload, now you actually have live pods changing flags. So maybe you launch something out as a version with it behind a flag, and you turn it on and then you turn it off. And the nice thing is you can do it on a per pod basis. So, there's fancier ways of doing that with Canary as well and things like this. But if you have feature flags, you also indirectly have a throttling system. So you can have a value as a label in your chart of how much batch post requests should I do at a time? How many messages should I fetch at a time? And you might think, well, what's the point? Why do I care? Well, if you ever had like thundering herd problems, or when your system's in fire and you're just like, oh God, like I just wish we could stop all the consumers from reading or reduce it. There's too many. Well, it's nice being able to just go in and change a value from 100 to 50. And now your consumers, instead of getting like 1,000 messages a second, are now all getting 500 at half the pace or whatever it is. And you could set it to 0, so full stop. So like it's very nice having some flexibility on the operation side of just having control and throttling and reducing. And the nice thing is you also have a break glass. Is how many times as devs we're like, man, we would have this information if we could just turn on debug, but debug is way too many logs. Well, if you have a way of turning on and off things, and you can do it on a single pod, and you find a pod that's not working correctly, great. Like you change the logging level to debug. And if your application code is watching this file and it reloads the logger to have debug on, I can just like that on a single pod turn on debug, and then I can turn it off just like that. As a dev or as an SRE, which is super powerful. And you can do it all pods, single pod, whatever you want. Like it just becomes very, very, very powerful. So that's that. I think it's just a very simplistic approach to getting a lot of benefits. And it doesn't require implementing a whole separate system or something complex. You're piggybacking on the existing stuff in Kubernetes, like labels. And then you're just passing those labels down into your application. Or the other case was for CPU and memory. You're defined that in the infrastructure charts, but now your application is aware of that. So it might do things based off of how much memory allocation it has. So you might say like, oh, for every 100 megs, I'm going to send 100 messages. And then if anyone updates the chart or the YAML, you don't need to have anything in the code changed. If you just have the environment variable there and whatnot, and it's great. DNS resolution. So this one gets a little into the weeds of probably things that most of you don't even spend time doing, but so I think it's fair that most people who deploy their application Kubernetes think that you ask for google.com and the resolution works like this. This is the normal expected behavior for most part that you would expect. You have, in this case, Docker, so you have a container of any type, and it's going to go out to Google name server, and that's how it's going to get DNS resolution, right? So this is what can actually happen before the Google DNS. It does depend on the language you're using, and it does depend on the type of Docker container you deployed out to prod. So what can actually happen is your Docker container, or whatever container it may be, but in this case we'll just say it's Docker. If you're using like Alpine, which most people like using because it's the bare minimum and it doesn't come with any extra packages, it also means it doesn't come with the NSCD, name server cache daemon, which means that your container doesn't have DNS cache. Now, when you run on your local, you don't care because guess what? Your computer has that. In Kubernetes, a lot of times they don't. A lot of times they're like, that's not my job. My job is to ask core DNS. So I'm going to go to core DNS and ask core DNS for your record resolution. And then it's going to have a cache miss, or it's, if it has a cache miss, it will actually go out to Google name server. And if it doesn't have a cache miss, then obviously it would serve out. But you just added a whole bunch of latency. Now, the exception is if you're in Java world, The JVM has to do everything, and everything, I mean everything. They have their own implementation. So even if you don't have DNS cache, the JVM itself will have DNS cache. I don't know why, but it just will. But if you're in Node.js, for example, it won't. It will do the kernel call. It will just ask the kernel, hey, I'm doing a DNS lookup, get address info. And in this case, you're not going to have a DNS caching daemon running. So it will say, I don't have any cache, and et cetera, as we got to this diagram. So why do we care? Well, if you're not in the JVM and you don't have a name server caching daemon, you can overwhelm core DNS because you can have a boatload of requests going to it. And you can also spend a ton of your time waiting just for DNS resolution. Like if you profile, you pull up your flame graphs or your APM, you will just be all of a sudden like, how is DNS resolution taking like 25 seconds? Well, because literally the diagram you're looking at is what's going on. Is you have a ton of your containers going out to core DNS, and core DNS is just getting overwhelmed with DNS requests. And this is significant mostly for like obviously third-party resolution, like whatever the API may be for like Google Drive or Shopify or whatever you're integrating with, especially if you have a ton of volume. So what's our developer checklist? The sooner the code's running on closer to a production environment, the better. Because like I said, if you run this on your dev box, you wouldn't notice this. And if you ran on staging, you probably wouldn't notice from any of the profiling, because if you don't have the massive amount of calls to like your third-party APIs, in which case most people don't because they don't get rate limited or throttled or anything like that. And they're like, oh, it's staged. We're not here to test the third party. Yeah, but it's not just testing third party. You're testing our underlying infrastructure on the DNS stuff. So obviously, we want to analyze profile APM and flame graphs, and we really want to look diffs between our low execution times and our high execution times, because if you did that for this, you would notice right away, all of a sudden, your DNS lookup stuff is starting to take a tremendous amount of time, and then you would start digging into why. Once again, you need to have a deep understanding, not just of the Kubernetes, but of your language, because in Node.js, we do DNS lookup, which is going to call get address info at the kernel. And in the JVM, it does its whole own implementation magic. So you have DNS cache actually in the JVM. So this is not an issue if you're running in the Java world. Now, our solution is actually Kubernetes, and 1.18 provides something called node local DNS cache. And you can turn that on, and then your nodes will have DNS cache, and you won't go out to core DNS as much, and you won't overwhelm core DNS. So, but most of us, when we're writing applications, don't even think about this. We literally are this. We think this is what's going to happen. So, not always the case, right? So, I think that was actually, that's it. Yeah. So, I hope you enjoyed it. If you had any more questions, or I'm glad you enjoyed it. Awesome. Yeah, awesome. The slide questions there, you can just ask in Twitch chat if you also want. If you ask in Twitch chat, I can just pin it and we can answer here. It doesn't have to be questions on what I covered. You might just have general dev questions about Kubernetes. That's fine too. And obviously, if you have something more elaborate that would take a ton of time to like write out and whatnot, I thought I left the email on this slide, but here, I'll go through it. That's the email. So some things get tricky when introducing Helm charts and whatnot. What would be a good entry point into learning Kubernetes for devs and engineers? So I think there is something, there is a course, I think it is, what is it called? In a Tech World Kubernetes. And and they have a really good course, and they'll prep you for the CKA, the Certified Kubernetes Associate course, I think, or whatever it is. So that's a really good spot on like the basics of Kubernetes itself. Like, hey, I want to know how to define the resources. I want to write, I want to run a Kubernetes cluster. I want to get it up and starting. I want to know how the control plane interacts. I want to know what core DNS is doing, how to configure core DNS, the much more inner workings, like, hey, I want to go on the DevOps or SRE kind of side. Just Tech World, literally just Google Tech World Kubernetes course. I think there's a smaller one for like $400 and a much not associated, not affiliated, by the way. So I just heard really good things, and there's a ton of YouTube resources the creator puts out as well. So I wouldn't say that introducing the Helm charts are so bad. It's pretty... Yeah, the Helm charts actually make your life a lot easier, because now you have something that's packaged and reproducible elsewhere, and you're not applying just random YAML files. For those not familiar, the Helm is like NPM or Gradle or pip of Kubernetes. It is basically a way of packaging up these YAML files in Kubernetes and having all of it get applied in a reproducible way. So you're basically installing whatever resources you have, like a load balancer, the pod, the deployment, the HPA. It's all bundled. So the same kind of concept as NPM from the JavaScript world. Yeah, I think that would be definitely the best course that would come to mind. Silence. Well, I enjoyed this. I hope everyone else got something of value. Yeah, the recordings are available on Twitch or on YouTube. The YouTube channel, not sure how I found this channel, but I'm happy I did. Oh, no problem. That's really good. The YouTube channel is also there. The live stream of this will be there for indefinite. And there are a ton of other videos I've done on like salary negotiation, how to become a software development manager, becoming a better dev, reviewing pull requests, giving better reviews on pull requests, less DevOpsy things, just general software. There are a couple DevOps things, but do I have Discord? I have a Discord of no one. No one in the Discord, but no, I don't really have a Discord. So yeah, and eventually will come. Eventually the Discord will come. But yeah, I have a series coming out in 2022 called Between Two Devs on the YouTube channel. And I basically just get in a call and interview someone from any aspect of being a developer. So from an indie dev to a Twitch streamer to the CTO of a startup to software development managers to people just all over the place, like front end, back end, SREs, talking about Kubernetes, talking about deployments, talking about, as I said, back end and front end, talking about like the change of the like software industry in general, running a startup, like being a founder and hiring devs. I don't want to say it's all over the place. I'm just saying like it just has a very wide range of audiences who are all developers, just very different paths. So that will be coming out 2022. Subscribe to the YouTube channel if you would like that. I think it'll be a blast. We already have like, I think 6 ready and another 6 scheduled. So I think I'll do them probably bi-weekly, releasing them. And yeah, this was fun. Until next time, I hope everyone enjoys their weekend. Like I said, you can reach me at that email if you had any follow-up other questions at all. Like I don't have Discord, but if you really need an answer, if you email that, I will give you an answer most likely if I have the time. But yeah, I will probably give you an answer. So just email. Adios. As you said, take care.